Okay, we are back to finish this problem on Excel. Let's go back to our prompt. Question 4, what percentage of the players make at least $1 million and what percent make at least 3 million? So what are we going to do? We are going to use our count if. And so we're going to nest a couple things because we want a percentage. But let's start with the first one. So I want to count if. So what is count if? It counts the numbers of cells within a range that meet a criteria. And so I am going to count if. What's my range? Once again, I made salary. So I'm going to count my salary. Now, I want to count the numbers that are greater than or equal to 1 million. So I'm going to have to string a couple of things together. So I cannot just go greater than or equal to this cell and close it, because what's going to happen? I'm going to get a problem with the formula, because you can't type in another equal sign just in like that without some kind of context, because what it's asking for, and we're going to hit OK. If I go back and look at the criteria, it's asking me to put in a number. It's asking me to put in a cell. So what we're going to do is we're going to build an expression. So what I'm going to do is I'm going to use the parenthesis sign. The quotation marks. That makes it just a text input instead of an equation. Now, I want to add that to my cell. How am I going to do that? I'm going to use the ampersand, Shift 7, the and sign. And so now what that does, notice that A37 now highlighted, because basically what Excel is going to do is it's going to take that text that I had, use the ampersand, attach it to the cell, and create one string. And so now when I do that, that will actually give me it will count the number of salaries that are greater than or equal to that A37. So if I do that, 438 players. Great. We want to get a percentage. So how do we do that? Well, I'm going to nest it in. I'm going to nest another one in. So I just need to divide that by the number of players. And so I'm going to use a count function. Just going to count the number of cells in the range, and once again we're going to go and use salary. So we're going to we're counting how many salaries are above 1 million, dividing it by the number of all salaries. And so 0.56, that is a percentage. Let's go home, and we will change that to percent. Now, since I have it put together that way, since salary is a named unit now, it's not going to change as we roll, as we index the equations down, but that A37 will. So to get the number of greater than 3 million, we just drag it down and we get 38. In fact, we'll take this out 1 because it's actually 38.2. Okay, so that's how we do that. A couple quick ways of putting that together. Okay, so now let's do a histogram and a box plot. So the first thing I'm going to do is we'll go insert. We will go and just put in our 2D column. We'll use that as our box plot. Excuse me, we'll use that as our histogram. Now it came in blank, which is fine. I'm going to right click on it and I'm going to go select data. And now I'm going to pick my data. And so what we need to do though is we need salary distribution. So we might actually have to change things up a little bit. So let's just cancel this and let's think how we want to do this. So just like with the last example, we're just going to want a number of counts for what the salary is. Okay. So why don't we right click on this again? We'll go select data. And so we're going to add series name. We don't need one because we're only going to have one thing on that. Let's go to data, and we're going to hit that salary. And I'm just going to type in salary, and there we go. It kind of broke it down by data point. But that's kind of not what we wanted, because now what it's done is it's just given us data point 1 and just went down and gave the values as we go. And so actually that's my fault because we started in a column chart. That's actually not what we want to do. So I just want to column. What we want to do is we want to look at, it doesn't want to do it that one. We want to go to insert. We actually want to pull out our histogram. And that is completely my fault because I forgot exactly where it is. So we're not going to use a column chart this time. We are going to use a histogram. And it's good because we're going to come back to because we've got our box and whiskers here that we're going to do in a minute. So I'm going to click on histogram. So once again, now we can go and select data, edit. The series values are going to be salary. And I've actually got to pull it from, I've got to have that data in there because it's in that one. So it is a defined value, but it's on that sheet. Okay, I guess I can't do it that way. Thought I could. That's fine. We're going to go histogram, and we're just going to select all the data. Going to get rid of this plus in the front. And just make sure it's our data. That's J2 to J878. Range I selected is too large. Okay, I'm not sure why Excel's messing with me, but okay, we'll do this where we pre-select the data. So instead of typing it in, which is what I usually like to do, but I'm just going to highlight all of this stuff and see if Excel will play nice with me. So insert histogram, and now it lets it in, which is fine. I don't know why it's doing that. So we're going to right click, we're going to go, right click up here, we're going to go move chart, and we're just going to move it over to answers. And then we'll drag that down here. And so now we really should add some titles, and down here will be, we'll just call this salary. And over here we'll call it frequency. And we'll come up here and call this salary distribution. Now we can see this is skewed. This is skewed to we're looking at the tail here. So this is skewed to the right. You would think, oh wait, that's where the most instances are, so it's skewed to the left. That's not the way it works. The skew is talking about where the tail is, the long tail in this case, which would be this, decrease, and then it goes out small. This would be the tail of the data. The tail is to the right, therefore the data distribution is skewed to the right, which is what we'd expect. We'd expect it to be heavily right skewed because more players are making the minimum than anything else. So there's our histograph. Let's see if we can make the box and whisker plot without the same kind of problem. So what we'll do is we'll pre-highlight the data again. As I said, I like building it, but for some reason my statistical stuff does not want to work with me today. So we're going to highlight all of our data. We'll go insert, go to our box and whisker, and there we go. So let's move chart, bring that into answers. And where did it drop our chart? Excel is not being nice to me today. Let's see, we'll zoom out. I dropped it way out of the league. You know what, I'm just going to cut this. It'll let me. View 100%. Okay. So we'll cut it. Because I don't know why I wanted to drop it all the way down there, but it wouldn't be a live lecture without some problems. So I'm going to Control V, paste that into place, and there we go. Let's rename this chart title Salary Distribution Box plot. Okay, and we're going to over here. Let's add axis titles. This will be salary. And we can get rid of that axis title. We don't need it. Get rid of that axis completely. Okay, and so now we have our box plot. What are we looking at? What does all of this mean? Now, what is the x? Well, the x is the mean. The bar is our median. So remember, the mean is the average of all these put together divided by the number of incidences. The median is we have just the same below it as above it, or to the left and to the right, however you want to look at it. So the box, this box itself is quartiles 1, 2, and 3. So basically the bottom of this box would be quartile 1, the top of the box would be quartile 3. So the whiskers, which is this line here on this little staff, and you can't really see it on the bottom because there's not a lot of room, but those extend above and below quartile 3 and quartile 1 by 1.5 times the interquartile range. And so the dots, you notice the dots there's none in between the top and the bottom, so inside the whiskers. These dots are all the values outside of those whiskers. So anything that's above 1.5 times the interquartile range above 3. So that's so it's showing you any variations outside of that. So the really high end stuff. So as looking at this, so which is better for this question, a histogram or box plot? Well, a histogram is generally preferred when visualizing a single distribution because it's just really easy to see kind of what's going on. Where does the box plot end up being more desirable? And that's when we're looking at multiple distributions side by side. So we'd have a box plot here and one here and one here. And then we can look to see what the differences, what the changes are. Okay, so there's our statistical data for problem 2.3 in Excel. So the next video, we will take a look at how do we put this together in Tableau.